Welcome, everybody, to this session. I know the time is a little bit late during the day, and I know you've got a pub crawl ahead of you, so things are going to improve from here. The session today is called The Perimeter is Dead, Long Live the Perimeters, which will explore the evolving concept of perimeter in the public cloud. My name is Roy Feintuch. I'm the co-founder and CTO of Dome9 Security, which is now a Checkpoint company. And my voice is not 100%, so I hope you'll bear with me. The idea for the topic of this session came after spending about 7 years in the space of enterprise adoption of the private cloud and witnessing firsthand the challenges and the evolution of what we conceive as perimeter. In order to start, let's go back to where we were a few years ago. In the good old days of this on-prem infrastructure, we had a very strong notion of perimeter, right? We had our walls of our data centers. We had armed forces or a security guard. We had our own network that we controlled, and there we placed network security devices in various strategic places, especially at the gateway. These devices, these enterprise-grade security, network security devices, provided us very strong notion of security with great advanced capabilities, because every packet could be inspected by these devices. Then those network devices gave us all sorts of threat prevention, anti-bot, anti-malware, next generation firewall, deep packet inspection, application awareness, user attribution to network flows, and all these kind of things. But then something happened. The public cloud happened. And that was a very dramatic change. That was a very dramatic change to the way that we could deploy our big boxes. So first of all, we had nowhere to install, to deploy our boxes. But it was not about that, because the traditional network security vendors have evolved and created a virtualized version of their software. But the public cloud was also different in the sense that we had all sorts of auto-scaled infrastructure. We had all sorts of platform services, ELB, Lambda, containers, and these were very different animals. So what was the solution? What is a poor man's security admin to do? Well, the solution for that was to take the good parts from this enterprise network security technology, make sure we have hardened our perimeter, our network perimeter, so now we can deploy these network devices in a cloud-friendly way, as a virtual appliance, auto-scaled, and that protect our perimeter of our network, our VPC. Can even use in all sorts of transit VPC scenarios, so to provide some kind of basic segmentation. But then top that with the native controls that the public cloud provides us. And let's examine for a second what Amazon provides us in order to define, to secure our networks. So we have the notion of VPC, an isolated data center. We've got within we've got subnets that we can control. We've got network ACLs. We've got route tables, and we've got security groups. These kind of cloud-native firewalls that have this property of being able to cope with elastic workloads, and also being aware of those platform services, like, again, Lambda function, or an RDS, or an ELB. These are all members in the big family of the Amazon network security infrastructure. So these technologies allowed us to create very tight microsegmentation of our networks, while still having this robust network perimeter for north-south traffic. So it seems that we're done, and you can all go and enjoy your drinks. Sadly, you still have 50 minutes with me. And this session is going to cover the evolving perimeter concept in the public cloud. There is no timer here, so if you can just signal to me 10 minutes before. Okay. So the public cloud is a very different beast. And by its name, it's public by nature. Okay, public cloud, it makes sense, public by nature. It means that the control plane of the cloud, as well as the actual services, are public by nature. And we'll examine that a little bit. Now, the actual services that Amazon AWS provides us, they provide us around 140 services. And I know that, I counted that a few months ago. But with the stuff that was already announced and the stuff that we know that will be announced tomorrow, you can top it to 150 at least. And what's special about these services is that many of them are managed platform services. What that means? It means that we do not have access to the bare infrastructure that comprise these services, right? We have now, as consumers of these services, we have very well-defined but strict control plane to configure them. And every one of these services is a completely different universe. Amazon are known for their two pizza operational model. The two pizza mentality means that every service can be fed by two pizzas. It means that we have a lot of very different teams and a lot of different ways to do things. Let's see what does it mean to us. And the strong notion that I want you to take from this session is that the network perimeter is now just one out of many perimeters. Because if you think about it, every one of these 150 services could be considered as a perimeter for your organization. And in order to make that less vague and more concrete, it's time to drill down. So I did some work in order to make that fit into our minds, and I set that into 4 distinct categories. So the first, and these all perimeters, again, these are new kinds of perimeters that we cannot protect by using a network security device. So the categories are like that. Data perimeters, basically allowing unauthorized users to access, read, modify our data. We've got compute perimeters, which means that third party can access and run code in our environment. The other one is messaging perimeters. Again, providing external entities the ability to read and post messages into our backend systems. And the last one, it's the cloud control plane, or the cloud control plane identity perimeter, which basically allows external entity the full keys to the kingdom. Let's start and examine these. Okay, so the first category of perimeters is the data perimeters. Basically allowing unauthorized users to read, modify, and delete your private data. And I'm sure you can guess what will be my next slide. Well, Amazon S3 is the most famous service from this aspect of data leaks and data compromise. This is also the first service that Amazon AWS created, even before the EC2. And this is the most successful file and object storage in the world. Its authorization scheme shows the signs of its evolution. And we've got many layers and technology that were developed in different times. Some of that was developed when XML was cool, and some of that when JSON was cooler. And then we have all sorts of policies. We have policies that are set on the bucket, policies that are set on the objects, and even these policies have multiple languages or multiple versions. We've got the ACLs, and we've got the the resource policies. And we also have IAM policies that govern that. So the fact that we have a very successful service with lots of people using it, lots of companies using it, and the fact that it has a complex authorization scheme, it means that every few weeks we find some other data leak, compromise by the ecosystem. And of course, misconfigured bucket can mean that either your private data can be read by external parties, or that if you provide world write or world delete permissions, it could be a deletion or manipulation of your private data. We'll not get into each perimeter regarding what you should do, but the general scheme would be something like that. Understand the configuration realm, understand the risk, and then develop some automated system processes that will able to catch those misconfiguration and remediate them. The next perimeter is a little bit more subtle. And we're talking about the EBS, and not the EBS service itself. EBS, by the way, the Elastic Block Storage Service, the virtual hard disk. This service has a nice property. It allows us to create to quickly create backups or snapshots. Now, these snapshots can be made public. Sometimes it's by purpose, by people misusing or abusing this capability, and especially to share data between teams, between people. And we've seen cases of companies or a developer or some maybe a data scientist that makes an EBS snapshot public, so his peer can create a virtual hard disk, an EBS out of that snapshot, and then load up the data to its own machines. So this is, of course, not the way to share data. So right now, while we're speaking, there are tons of public EBS snapshots that contain private data. And we will share this, the slides. But in the link below, there is a very interesting article. So some company just created volumes, attached these volumes out of all those public EBS snapshots, and then started to analyze the data there. And what they found was very horrifying, from stuff like genome data to private SSH keys. It's all lying there right now as we speak. The next perimeter which we'll explore is the AMI, or Amazon Machine Image. Some people call it AMI. I'm not one of them. I don't like you guys. And so these AMIs, AMI is a full image of a virtual machine. AMIs can be shared with specific accounts, but also can be made public images. Now that makes sense. You know, some companies, for example, I don't know, Red Hat, right? Open source product company. Yeah, it makes sense for them to publish their versions of their software as a public AMIs. But I guess that for the audience here in the crowd, for 99% of you, exposing your AMIs means that you might be leaking proprietary data, all sorts of IP, intellectual properties, and all sorts of SSH, DB credentials that for some reason you baked into your images rather than reading them from a secured configuration. So one thing to note, or to kind of to check with your teams, in your environments, when the DevOps infrastructure, the build systems, is deployed or are deployed in a different Amazon account than where your production system is deployed. So this means that there is some image sharing between those environments, and hopefully those image sharing are done securely and only whitelisting the target AWS accounts relevant. But this is something for you to check. By the way, all these links below are links to some other and more explanations for these. The next perimeter might be a bit familiar. So RDS, a super successful managed relational database servers by AWS with MySQL, Postgres, MS SQL, Oracle. Didn't write it. And this service, very much like the EBS, provides a very simple to use snapshot capability, backup capability. Now, this snapshot too can be made public. Again, I'm sure there are companies where it makes sense for them. I don't know, if you have some open, public, knowledge base, database of, I don't know, IP reputation or maps to geolocation or I don't know. But for, I'm sure 99.9% of you, exposing your databases will be a compromise of your own private data or your customers' data. So again, something for you to note. The next one sounds less dramatic, but it is important perimeter. CloudWatch logs perimeter. And CloudWatch logs is a managed log aggregation and query service provided by AWS. It's becoming more and more popular as companies are starting to use more Lambda and containers. It's a kind of a natural thing for these technologies. So logs can contain private data, right? Think about your application logs and what they contain. They can contain all sorts of user transactions and internal stuff, and of course, IPs and emails and stuff like that. And these are the things that you know. There are many things that you do not know which are logged there. And a few months ago, both Twitter and GitHub on the same day or day after find out that they're logging their users' credentials in the log file, right? It's super, super challenging to protect against some random developer stupidity, or not stupidity, right? Mistake. And someone probably logged the request parameters of the change password workflow, or forgot password workflow, and then you've got in your log system, non-encrypted, no nothing, lying there, clear text passwords of all your users. So, okay. So these CloudWatch logs has the concept of cross-account subscription. Means these can be part of a perimeter that share your data with other environments. Now, this could be other accounts that you control, but this could be also accounts related to third parties or even to malicious actors that just set this subscription, and now all your data is flowing into another Amazon account controlled by a malicious party. Okay, the next one I'm going to cover is Elasticsearch service, the Amazon managed Elasticsearch service. And I'm sure most of you are familiar with this, what is Elasticsearch. Until recently, and this is kind of recently, I think Amazon launched that about a year ago. The only deployment option was outside the VPC, kind of floating in an Amazon account controlled by Amazon, where the only way for you to hook in your security stuff, your security configuration, it was through a service-specific configuration, where you could use some IAM or some IP restriction in a very, very specific technique to that service, to the managed Elasticsearch. Now it's okay. You can put it inside your VPC and enjoy your traditional network security infrastructure to protect it. But what does it mean? It means that right now most of the Elasticsearch instances are out there in the public Amazon-controlled account, only protected by user configuration of IP restriction or some IAM protection. I don't know if you see this tweet, and that was kind of a large-scale attack about a few months, maybe a year ago, where lots of MongoDB instances and Elasticsearch instances were ransomed. And because, again, it's not trivial, and people need to know that they need to protect these services, and they are protected in a non-standard way, right, in a service-only configuration. So here we saw about 35,000 of Elasticsearch servers that were compromised, and most of them were on AWS, also because of the size and the market share of AWS. And of course, the damage here is obvious for all, right? Leaking your private data, manipulation or deletion of your private data. The last one in the data perimeter is the KMS perimeter. So KMS is the Amazon AWS fully managed encryption key management service. Super important service for any security-minded company. Now, what's interesting about it, that every encryption key in the KMS carries its own key policy, which basically tells what or who can access the key, delete it, rotate it, or use it to decrypt content. So it means that every one of your KMS keys contain this kind of snowflake configuration that needs to be examined in order to make sure that you're applying least privilege concept. And you not doing that means that if in combination with another sorts of data theft, maybe someone stole some of your private data which was encrypted, but now with the addition of this encryption key, now this data can be read. And in case of someone deleting your private keys, that's it. From here and now on, your data is a bunch of bits and bytes, pretty gibberish. And that's, of course, not a good thing to have. So with this happy thought, I think it's time to move to the next perimeter, which is the compute perimeters. And by that, we mean allowing external entities to run code inside your environment. The next slide will probably be obvious too. AWS Lambda is a perimeter. Lambda function or Lambda service, newish serverless computing platform. I don't know why I said that. It's 4 years now, but it feels like serverless is newish. Lambda can be run inside your VPC and can access your internal private stuff that runs inside your VPC. And also Lambda can be run in an AWS controlled global account, but that does not mean it cannot access your private data. That might be misleading, because now some of your data, again, resides on publicly accessible AWS services, S3, DynamoDB, all this kind of stuff that can, so this Lambda function using the right role and permission can access that data too. So it doesn't matter if it's running inside your VPC or not inside the VPC, the Lambda function can access private data. Now, Lambda function can be invoked through event subscriptions, which means that automatically Amazon invokes the Lambda in response to some event in your system, or it can be invoked manually. Now, each Lambda function also carries a little resource policy that in addition to the policy of what the Lambda can do, the policy that is assigned to the execution role of the Lambda, this Lambda carries also a resource policy that defines or determines who can invoke this Lambda function. Now, and of course, you can authorize other parties and random Amazon users to invoke your private Lambda functions. Now, in addition to that, this policy is not even displayed in the UI, at least the last time I checked. So again, Lambda function is part of your perimeter. And running unauthorized Lambda functions in your environment, again, it could be a way to trick your system or to access private data, or if someone can have another way to control the Lambda function, it can be used just to mine Bitcoin or something like that. The next perimeter is kind of related to that, is the Amazon API Gateway perimeter. Now that makes sense, right? The API Gateway is a gateway. It is by design the perimeter. And Amazon API Gateway can be public or private, used for internal APIs. But the API Gateway, again, a fully managed front end, can connect to two targets. It can connect into your instances that might reside in your VPC, or it can be connected to a Lambda function. Now, the path from the API gateway into your EC2 instances that resides in your VPC are controlled by your standard VPC networking infrastructure. But the path from the API gateway into the Lambda function cannot be governed by a network security construct. And even if you try to set security groups for your Lambda function and have strict inbound policy, which is possible, it will not work, and the API gateway will be able to invoke the Lambda if that is the service configuration. So a misconfigured API gateway, again, can mean that unauthorized user, and this is random people from the internet, can directly connect into private resources, private Lambda functions inside your environment. Amazon ECR as a perimeter, right? So ECR is the Elastic Container Registry. This is an AWS managed Docker registry. For those of you who are not familiar with that, it's where the images, the Docker images, go to sleep before they are being pulled and invoked and recreated as live containers. So the Amazon ECR too can have resource policies that govern who can do what. And what do you do with the registry? You can push new images, you can pull and read images, and that's basically it. So a misconfiguration in your ECR, in your Docker registry, can mean that third parties can do first pull your images, pull your code, and again, exposing your intellectual property, your code, your fancy algorithms, whatever, or people, if they have opportunity to push stuff into your Docker registry, it means that someone can push rogue code, and then you'll run it inside your environment. And a good rogue code is a code that actually performs the original intent of the code, but doing some side jobs. These side jobs could be crypto mining, or these side jobs could be sniffing some traffic, logging your user activity, accessing your private data. So again, not a good thing to have running inside your environment. Okay, that was the compute perimeter, and it's time to explore the messaging perimeters. Basically allowing entities to send or receive messages from private systems. In order not to make it super boring, I've condensed 3 messaging services into one slide. So we're going to talk about the simple, it was SNS, it was a mistake, simple notification service, simple queue service, and Kinesis. All these 3 kind of similar messaging services provided by AWS share one common property. All these 3 services expose all sorts of configuration, resource-based policy that can allow third parties to send, receive, or delete messages. So again, a misconfigured service, and these services are usually the internal backbone of your systems, right? These allow interconnected backend services to communicate with each other. So a misconfigured service could allow any unauthorized entity to access and send all these messages to your private systems. And again, trying to query data or pushing wrong stuff and bypassing all sorts of the perimeter and the application level constraint that you put in place. Okay, that was quick. The next concept or the next perimeter that I would like to explore is the cloud control plane perimeter. And basically thinking like the metrics and looking from the outside. So leave all those services configuration and network infrastructure and all the services configuration. If the attackers get access to the main credentials that control this entire universe, then they can do anything. So the cloud control plane or the cloud control plane identity perimeter is basically I'm talking about the concept of the public cloud, again, brings an always-on, internet accessible web console and management APIs, right? Compare or contrast that to previous IT management systems that we had in the on-prem world. They were buried deep behind our enterprise firewall, and so all sorts of admin console might have been able to access from the inside, but definitely not from the outside. A public cloud is different. The public cloud, by definition, the control plane is out there in the internet. And again, console access and the APIs. So because it's always accessible, it means that now our IAM users and IAM roles become part of our perimeter. So a compromise in an IAM user and IAM role means full access to any cloud resource, deleting databases, creating snapshots, diverting your traffic through Route 53 to another DNS, to another server. So full control over our infrastructure. Now, it's not that complicated to have compromised IAM user and IAM roles. So for IAM users, again, it's users. Mistakes happen. So we can have compromised credentials. We could have some developer that deploying its Amazon API keys to GitHub, which, by the way, Amazon monitors, but the attacker is also monitoring. And all sorts of attacks on the developer laptop, rogue browser extension. It could be a lot of things. And to compromise an IAM role, well, you don't have the credentials there, but there it's usually accessible again to third parties through cross-account roles. So again, IAM role is another boundary, another perimeter for your organization, which can be exposed to third parties. And of course, compromised machines or application in your environment can leak the roles by if the attacker is now querying the AWS metadata service that exists on each Amazon EC2 instance, for example, they can get the session token of that role, and from there act as that role. And if that role was a privileged admin role, then this attacker would be able to do whatever that role had permissions to. So I'm not going to get exactly to how to mitigate and protect against that, because that deserves a topic by itself. But basically, we're talking about best practices of credentials storage, operational hygiene, where how to put when to use credentials and when not to use credentials, when to use roles. Also some automated tools and mechanism that allows first least privilege concept and dynamically allocating and elevating privileges. As a recap from the thing that covered, this is a good slide, I think, to copy because it contains most of this information. We covered a few perimeters that cannot be protected by this network firewall. We covered the data perimeters, which allow users to read, modify, delete their data. And again, all these services. And again, I want, these are just a few services that I covered here. This session is not intended as the full complete list to all the theoretical perimeters in the cloud. I gave a few examples. And here, for example, in data perimeters, I didn't mention Glacier. I'm sure it has the same similar properties as S3. I didn't mention, I don't know, Glue and Athena, right? So they could be one of these two. In the compute perimeters, again, Lambda, API gateway, always for other third parties to run code inside your environment. The messaging perimeters and the identity perimeters that allow external entities full control over the virtualized data center. So this is a good slide. And this is a little plug for why we are here. We are Dome9 Security, which is a SaaS platform for compliance and automation. And through the last seven years, we've been working with some of the largest customers of Amazon and help them to manage and protect their system. So this intimate work with these customers, and there are many, many more that we cannot put their logos, especially from the financial industry. These kind of customers gave us the insights into all the challenges. So this is why we created a system that natively talks the cloud language. A system that can understand what is a Lambda function, what is an RDS, what is an ELB, and then allows the users to visualize them, to test them against industry best practices, to run automatic scans for these environments and even automatic remediation. And I think it's very relevant that we were acquired a month ago by Checkpoint Software, which is a happy thing for us, especially the founding team. And I think that really resonates well with the concept of this talk, because you've got a leading network security company, probably the company that invented the network security industry, and by them acquiring Dome9, it's an understanding of that the perimeter concept is evolving, and now we've got more areas to defend. So thank you for that. And by that, I would like to thank you for, again, spending this last 40 minutes with me before the pub crawl. If you'd like to learn more, you can contact us there. And if you'd like to go and talk to us in private, then we have a booth here, and there's also the pub crawl now, where we're hosting a session at the Chica, right? So you're more than welcome to visit us there. If you liked, and only if you like this session, feel free to complete the session survey. If not, then don't bother, waste of time. And I think we have a few more minutes, let's say about 10 minutes, so we can allocate that to some open Q&A. So there are 2 mics over here, so feel free, don't be shy, and feel free to ask questions. Yes.
First of all, thank you very much. That was a great presentation, very helpful.
Thank you very much.
A really good overview of the Amazon services as well. So my question is just about, now that you're part of Checkpoint, if you could just talk about the functions that CloudGuard has and how Dome9 will complement that.
Okay, that's a good question. And so the Checkpoint CloudGuard, it's a family of products, but you're probably referring to the CloudGuard IaaS, which operates on AWS. And this is Checkpoint's battle-proofing network security device that provides all those kind of properties that I mentioned in the beginning. A very strong sense of perimeter, deep packet inspection, engine firewall, application awareness. And that is a really solid foundation to make your perimeter, or even to make your infrastructure, network infrastructure, for example, transit VPCs and VPC to VPC segmentation. That's a very good technology for that. But that technology can and should be augmented by cloud-aware system like the Dome9 that helps you to either control the security groups and the VPC and the routing configuration, as well all these other non-networking boundaries. Any other questions? Yes. Mm-hmm.
Very well, and it's much more complex even than what you depicted. You gave examples of each vector, but in your vision, you are telling us these are the problems, right? But in your vision, how a complex company, either service provider or enterprise, I don't care, can cope with this complexity effectively? Because it's
I'll repeat that because this session is recorded and some of the people might not have heard. So the notion of the question is, hey, what you said is great, but it sounds very complex, and it's not only that, because there's much more things that you didn't cover, and not only on top of that, I'm adding to your question, Amazon continuously creating new stuff, new services, and how could an enterprise or service provider can cope with this amount of knowledge and change? And frankly, there are no easy one silver bullet things, but I can tell you that there are products like Dome9 or other competitive products that at least provides you the basic of security best practices, CIS benchmark for your AWS environment, so you can start at least from a sane baseline. But there is no replacement for if you're going deep into AWS, then actually understanding the material, either through gathering this knowledge internally or getting consultants to build a nice foundations and good guardrails for the operational team or for the development teams to operate in. A very strong notion and security concept that I truly believe it, that infrastructure and security infrastructure team should build a strong set of guardrails in place and let the development team run, but within the boundaries of those guardrails. Okay, so it seems like there are no other questions, so thank you very much for your time. All the best.